Hi and welcome. This time around we have a quick project. The welding group that I work for, do consulting for, they're making their own helium leak detector and they're building it from scratch. And they have a flange that comes up through a table that's got a 1-inch pipe on it. Turbomolecular pump that's underneath, it's a pretty heavy item. There is a bracket on it, but they don't want it moving around a lot. So it's held below right at the turbomolecular pump, and they want the pipe that comes off of it also to be clamped in place. So we're going to make a section of this that is going to fit through the 2-inch diameter hole in the table and fit in there and keep it centered, and then the rest of it will clamp on the 1-inch pipe to keep it going through the table, as well as have the split section being able to screw to the tabletop itself to keep it from falling down. So all those things in one piece, got a design in mind. Just going to start by squaring up the face of this stock. Don't need to go all the way in because we're going to drill a 1-inch hole through here. I think this material is rigid enough. I don't need to put it in the center. They say 2.5 times the diameter. I think this applies, but I'm not 100% certain. We're going to go in 3/4 of an inch. And we're going to take this down to 2-inch diameter. I'm just going to go 100 thousandths passes. Okay. I want to put a little bit of taper on this guy here. Several ways I could do it, but what I'm thinking about is angling my tool post here and just using one of my inserts as a form tool. Now that this thing's not moving, you can see that I've got a 1-degree taper I dialed in. I just rotated my compound. This is all perpendicular, and I rotated my compound 1 degree. We'll see if we can actually pull this off. Let's see. Let's go up to about here. That should do it. That should let it slide in. That's a nice little paper thin chip there. Just going to drill a hole. It's not going to make it. I think I'm going to take this guy over to the bandsaw and cut it off that way. I do have a different style parting blade, but they tend to break really easily. I haven't had really good luck with them, so I think we're just going to try this guy over at the bandsaw and then face it after. I was going to make this smooth and then I was going to face the center part, but it actually looks really good like that, I think. So I'm just going to leave this rough cut material there as a contrast. So I need to find the center of this hole here, which would be the center of this width, but this edge finder can't really find the edge of this surface here, because the top part will contact before the tip does. It's a problem I've had many times before. So what I'm trying to do is I've taken this gauge block to the part I didn't taper. Tapering was a mistake doing it early, but I guess I kind of had to. It would have been hard to do after. And so I put the gauge block sticking out, and now I'm just going to come in while holding it down flush. This isn't a super precision operation. And X 1/2, 2.1025. So I'm going to go back to this side over here, see if I get the same thing. Really close, within a couple thousandths, which is more than good enough. So then I need to find the center of this part here for when I drill a hole through, but I also need to use an end mill to cut in here. So I also need to find the height of this guy, because I want to come down about 3/4 of an inch to put a pair of flats actually symmetrically for a 1/4 screw to clamp the side together, because I'm going to cut this whole part in half when I'm done. Now I'm going to drill holes at 1.5 inches from center, and we're going to go all the way through. This is the tap drill size. Next I have to drill the body drill to halfway point, and I'll go just a little bit past halfway point. Use my quill DRO, set my 0 here, go back to 1.5, and halfway is a total depth of 1.865. There we go, 1.9, so that should be just past halfway. Now I'm going to tap the 2 holes. I've got a pulley tap here that's 1/4 so I should be able to reach down in there and tap this guy. We're going to tap it all the way through. I think I'll make the clearance hole a little bit bigger. Go one size up, a 1/64 larger, just to make it so that the threads don't bite on the way in. That is a 1/4 inch drill bit. That's 10. So to use the bolt circle setting on my DRO and to get this right, what I had to do was I set it at 3-inch diameter hole, bolt circle, starting point 90 degrees, because this is 0 over here. Then 3 holes, not 4. Then I want them 120 apart. So this is 90 plus 120 plus 240. So 90 plus 240 is 330. So the ending angle is 330. If you make the ending angle 360, it throws the last hole off. And so that's going to put one equidistant on this side at 3 inches off center. And that's what I'm looking for. All right, I got this guy in here centered, so I'm going to scribe a center line that we can take over to the bandsaw. So we've got our cut line now. Leaves plenty of material on top, plenty of threads on the bottom. Kind of bummed that these 2 holes went into the threads, but we can work around that. I don't need to use these 2 holes. Here's the completed part. This is the bottom. This slides in the hole. This is the top. And we've got some holes here. You can use some wood screws. He can use wood screws in here if he wants. If he needs to go 1/4, you can only use these 2 holes. These are right on the edge of these holes. It just barely missed them. So I go any larger, it's going to hit them. I didn't calculate that in. Should have laid this thing out in 3D CAD first, and I would have caught that. But in any case, I guess that's the part done. It clamps really well, holds nicely, and doesn't look terrible. And it's in an industrial setting, so I think we're going to be good.